Okay, so here's one more solution for today. It is solution for question 3 on page 503. It's text and test 4, and it's a proof by induction with divisibility. So in this question, we're trying to prove that 9 to the n minus 5 to the n is divisible by 4 when n is an element of n. So the normal steps apply. P to the 1 first of all gives me 9 to the 1 minus 5 to the 1, which evaluates simply as 4. And don't forget, for divisibility, we'll show divisibility by factorization. So 4 is 4 times 1. 4 is one factor, 1 is the other factor, definitely divisible by 4. I mean, it's pretty obvious here, but it's nice to kind of continue, to start off with themes you mean to continue throughout the rest of the question. And so we'll just state that this is true, and then we'll move on to pk. So for pk, we've got 9 to the k minus 5 to the k, and I'm going to assume this is divisible by 4. So if it's divisible by 4, I'm going to call it 4a. So 4 is one of its factors, and a is the other factor. Obviously, I can't evaluate this 9 to the k minus 5 to the k, so I don't know exactly what a is, but I'm going to assume that it's there. So I'm going to say assume true for this. On we go to pk plus 1. So I'm just substituting in k plus 1 here for my n's. And the key is going to be to rewrite this statement by splitting up each term because of the addition in the exponent, which leads me to 9 to the k times 9 to the 1 minus 5 to the k times 5 to the 1. Okay, so now at this stage, I'm looking for divisibility by 4. So I'm going to take my coefficients 9 and 5 and I want to split them up. Or at least I could split them both up. But actually, in practice, what's easier is just to split the larger one. And I'm going to split it up into 4 and 5. And you can clearly see I'm getting the 4 here from the divisibility by 4 that I'm looking for in the question. Now, at this stage, if you look at this line that I've just written down, it may make sense to you why I didn't bother splitting up the 5 that's in front of the 5 to the power of k. Because if I look at what I have here, having split up the 9, I've got 5 by 9 to the k minus 5 by 5 to the k. And this echoes my pk line previously in the question. And these two terms that I have at this stage now, they have a common factor of 5. So I'm going to actually factorize that out. And that reveals quite clearly my pk line. And since I made an assumption earlier on that this was equal to 4a, I can now replace this part of the statement with 4a. And at this point now, I can see that each term has a factor of 4. So I can factorize 4 out of the whole expression, leaving me with 4 times 9 to the k plus 5a, which allows me to conclude that pk plus 1 is true. And then I simply wrap up as usual. And this ending doesn't really vary from question to question.